Here's a discussion of methods to provide fire pump power when dealing with ground fault protection, specifically in situations where you have both utility and generator feeds. The challenge arises due to parallel paths back to the neutral point, which can interfere with ground fault sensing. This is a common concern in high-rise projects where a fire pump is legally required with a standby power source. Several solutions exist to address this issue. One method is to use a ground fault isolation device, often abbreviated as GFID. This device is installed on the utility side of the transfer switch. The GFID's purpose is to detect ground fault specifically on the utility feeder. If a fault is detected, the GFID opens the circuit, thus isolating the fault. This approach is effective because it allows for parallel ground paths to exist without interfering with the crucial ground fault sensing needed for the fire pump system. Another solution involves employing a double-ended power supply system with an automatic transfer switch. In this setup, you utilize two separate utility transformers to feed the fire pump. Each transformer connects to its own separate transfer switch. These transfer switches are automatic, meaning they can switch between the utility power source and the standby power source, usually a generator, without manual intervention. The key advantage here is the physical isolation of ground paths. By using separate transformers, you eliminate the parallel ground paths that cause interference with ground fault detection. This provides a cleaner, more reliable ground fault sensing system. A third option is to consider a phase-separated power supply. In this case, you would use two separate utility feeders, ideally originating from different transformers or substations. Each of these feeders is connected to a dedicated transfer switch specifically for the fire pump. Similar to the double-ended approach, phase separation provides physical isolation, which minimizes or eliminates parallel ground paths that can compromise ground fault protection. A fourth method involves a resistance-grounded neutral power supply. This requires using a resistance-grounded neutral transformer for the utility power supply. This type of transformer is designed to limit the ground fault current to a manageable level. By limiting the current, you can then implement ground fault detection using a ground fault relay. The relay is calibrated to detect the limited ground fault current and take appropriate action. It is important to note that using a resistance-grounded neutral system may require coordination with the utility company to ensure it meets their requirements and doesn't adversely affect their network. Regardless of the chosen method, there are several important considerations. Ensure that the transfer switch, including any ground fault isolation devices, are rated for the full load of the fire pump. The fire pump represents a significant electrical load, and all components must be sized accordingly. Thorough coordination with the utility company is essential to verify the availability and feasibility of any chosen method. Different utility companies have different requirements and capabilities, and it is essential to ensure compliance with their standards. Finally, always ensure compliance with all applicable codes and regulations, including the International Building Code, or IBC, and any local electrical codes. These codes dictate the specific requirements for fire pump installations and ground fault protection. Let's touch on common practices for these solutions. Ground fault isolation devices are frequently used in commercial and industrial applications where large rotor loads are present. The GFID provides targeted ground fault protection for critical equipment. Double-ended power supply systems are commonly implemented in high-rise buildings or other critical facilities where redundancy and reliability are paramount. Having two independent power sources ensures that the fire pump can operate even if one source fails. Phase-separated power supply systems are sometimes used in situations where circuit breaker coordination is required. By separating the phases, you can improve the coordination of circuit breakers and minimize the risk of nuisance tripping.